Welcome, everybody. We are very excited to have this seminar. I think, is this the first WMAS seminar where both Shure and Sennheiser are together?
Yes and no.
Yeah.
No, like I said, this is
we've
not
hung
the
out
first
before.
seminar where
Yeah.
Shure and Sennheiser are together, but we are really grateful that they're here together for us now. I want to introduce Chris Phillips
Hey guys.
from Sennheiser. Welcome. Ben Escobedo from Shure. And we are here to talk about WMAS. I'm going to be here sort of like playing don't pay no attention to the person behind the curtain. I may jump in occasionally. If you have questions, you want to hold them to the end? You want them to interrupt? How do you want to handle it?
I'm okay to keep it easy.
Yeah, like keep it
Yeah.
conversational. Yeah, that's fine.
All right, great. Well, without further ado, you guys take it away.
Do you want to go?
Sure. Yeah.
All right. This will be quick. This is the brief version of our approach to WMAS. So last year, in February, new regulations were passed with the FCC where we can now do wider transmission schemes where we have multiple carriers on them. So before February 15th, an unlicensed user could have a 200 kilohertz wide carrier, and that's what we're used to with point-to-point systems for wireless microphones, IFBs, and air monitors. And you could go up to 50 milliwatts. With the Part 74 license, you could go higher than that. After that ruling by the FCC, we're now able to do multiple channels. So WMAS is Wireless Multichannel Audio Systems on a wider carrier. And the goal of this is to be more spectrally efficient with the spectrum we have. We all know that we've had repacks. There's, always conversations about how we need to do the most with what we have in the UHF spectrum with PMSC devices. So now we can go up to 1 megahertz wide. The new regulation is up to 50 milliwatts, and up to 6 megahertz wide, so the width of a DTV channel in the US, we can go up to 100 milliwatts. And on those wider carriers, you wouldn't just do one channel, you can do many channels. So it's a multi-channel audio system. So our approach to this, and then I'm sure Ben's gonna talk about how they approach it. Now we have these new regulations, and we can design systems for these new wider carriers. So our approach is we have a 6 megahertz wide carrier where we're now able to do many channels on that 6 megahertz wide carrier bidirectionally. So if you have a scenario where there's 20 wireless mics and 8 IFBs, we can now share the carrier and all of them are operating on the same carrier. We can scale that depending on the use case, and there's always control back and forth. So traditionally, we would have many narrowband carriers in that 6 megahertz, and you'd have to frequency coordinate them in a way where they all played nicely together. Now they all share the same carrier. The reason why we approach this with the 6 megahertz wide approach is traditionally with narrowband systems, we have diversity antennas. And we need that because of phase cancellation and fading. With the wider carrier and the way that we approach it, we're able to put redundancy across this carrier where we can have many channels that if there is a phase cancellation or if somebody turns a wireless microphone on top of it, the information is still able to get through. So we're able to get many more channels than we could with narrowband carriers, and we can do them bidirectionally now. What the system looks like now in its first iteration is this. So we could do up to 64 channels, 32 in and 32 out in a 1 RU rack unit. I know a lot of you are doing film cart and work on film. In the future, we may have products that use this technology with DC power and things like that. Right now, it's a 1 RU dual power supply box. We can also have, because of the bidirectionality of it, we can have IFBs and microphones in the same pack working at the same time. So just going back and forth. And eventually, we'll develop more devices that work within the system, handheld microphones, little mini body packs, things like that, that can live in the ecosystem. So this is what it replaces. We used to have a big rack of gear because every one of these narrowband channels would need a receiver channel. Now we can scale it down and kind of make it roll in on a Pelican case. And then just a little bit about how many channels we can get. We talked about that spectral efficiency that we can do. You know, at a typical 6K quality, which is what we're thinking about narrowband microphones right now, we can do 32 microphones. We can do 16 stereo IEMs. Right now, we're limited by the audio I/O, so eventually we'll be able to do, you know, up to 128 audio links on that 6 megahertz carrier. And that's all with the thought in mind of being more spectrally efficient and using the spectrum and maximizing that on the WMAS carrier. So to kind of sum it up, just to think about it, because this is new, the big changes, before we had to do narrowband carriers, they had to be 200 kilohertz wide, we had to stay within that. Now we're able to do wider carriers up to 6 megahertz in the US. So that is the width of a DTV channel, and we can do multiple audio links on that same carrier. So that's the big change in a nutshell. And then I'll let Ben go, and then I look forward to the discussion and any questions you might have.
Yeah, thanks, Chris. Yeah, as Chris said, it's more of a regulatory construct. You know, WMAS is not a technology. It's not, you know, like it has to use a certain transmission mode. The rules basically say, for the first time ever, instead of just 200 kilohertz wide, you can use wider than that. You can use up to 6 meg of the whole TV channel in the US or 8 meg in Europe. Just because, you know, that you can do that, we approached it slightly differently. When the rules and regulations came about, as Chris was mentioning, we determined that it would be a great fit to put in our latest digital product, the Axiom Digital PSM. And I'm happy to say that that's like the first WMAS product. We've been shipping it for a few months now. However, it's not just WMAS, it does other modes and such too, which we'll get into. It's really simple. You know, it's not a technology. You can use more than 200 kilohertz as long as you're efficient with it, and there's output power regulations and restrictions still apply. I was, you know, proud to be involved with some of the early, like, you know, science project type of stuff. I remember going to the Ed Sullivan Theater a couple years ago with Paramount and the NAB organization, National Association of Broadcasters, and showing them what we've been working on and what they thought about it. The main pushback from the broadcasters and other users is that WMAS users may not be using it efficiently. And they were scared that, like, it does nobody a good service with all this brand new regulatory stuff if you take up like a large amount of space for one microphone. While you can do that technically, it's not fair to you, it's not fair to everybody else. And we kept that in mind as we kind of progressed with our approach to WMAS. Our approach to WMAS is pretty simple. In the 80 PSM, there's a mode called digital wideband, which is WMAS mode, and we are using on a quad receiver 4 stereo channels in 800 kilohertz. And that's, you could think of it, a better way to think of it is if I took a traditional PSM stereo channel, 4 of them, and just smashed them all together with 0 space in between, that's how it would look like. Another thing with WMAS is that you have to be aware that now that you're using a larger block, you're a larger target for interference. So it's great if you take up a large amount of space and you're efficient with it, but you know, what would happen if somebody interfered with you? Do you lose the whole block? Does your entire show or system go down? And our approach here, I don't know the magic behind it, but essentially if you take a hit on, say, channel 3, you'll just lose channel 3, and the rest of the channels will still be there. That also does mean that, you know, if channel 3 goes down, you have to move either channel 3 user to another spare WMAS block, or move the whole block using our ShowLink remote control, you know, Zigbee technology. So those are, you know, things that you have to think about as you're putting more eggs in one basket. What happens if that basket gets broken or one of those eggs gets broken? I have to have a way to, you know, seamlessly move it over, and we're using that with ShowLink. We talked, you know, WMAS is not just wireless microphones and IEMs or IFBs, but in the future it could be other things too, like conferencing systems or comm systems, talkback, you name it. It could be one or the other. Just because we can use this space, it doesn't necessarily mean that the system Chris was talking about is bidirectional. Yes, you absolutely can do that, but it doesn't have to be. It could be a one direction only, like the ADPSM. It could be a one direction only, like with just a handheld transmitter. This is just the beginning of this because, again, for the first time ever, we can use more than 200 kilohertz as long as we're efficient with it. This is just the beginning of like something kind of cool and something great. I'm sure we'll see a lot more systems taking advantage of this and hopefully using it responsibly. The benefits are basically that. You're more efficient because you can put more channels in the same amount of space. With the Axiom Digital PSM and the regular digital mode that uses traditional 200 kilohertz on each frequency, we can do about 17 channels of stereo in one television station. With the WMAS mode, we can do 28 channels of stereo, or double that, of course, for mono IFB use in the same amount of space. So it is more efficient using the WMAS mode in that instance versus narrowband. But those caveats still apply. There's a couple things to be careful that the larger the block, the bigger the target. And also the output power is going to be shared. There's a finite number, especially here in the US, there's a finite number of output power that you can have per box, per device. And as you add more users into that block, each one of those users is arguably going to get less output power per carrier. So your performance from a distance and range perspective with WMAS would be arguably less than using a traditional narrowband digital or narrowband analog type of carrier. So you got to kind of weigh those things out. Bigger target, but more efficient. What happens when I get interference? Am I going to get the same range and performance as I do with narrowband, digital or analog? Europe did it first. They passed these WMAS regulations, and the United States followed not too long after that. But it does leverage, kind of a scalable architecture. We envision like a world where WMAS will coexist with narrowband for some time. Nobody's throwing out all their, you still have analog stuff, right? I mean, there's still digital stuff, of course. In the near future, I'd say in the next 5 years or better, we're gonna see analog narrowband, digital narrowband, and WMAS all existing together, especially, for these events where you have like a news event or something and everybody brings their own stuff, and of course, it's all gonna be different manufacturers, different architecture, different technology, and it all has to work together. That's kind of the vision of what we thought here, and one of the reasons why we did add this to the Axiom Digital PSM, it's not the only mode. There's like over 40 or 50 different operational presets you can operate it in, including analog, digital narrowband, digital wideband, and point-to-point Axiom Digital. So we give you that like flexibility that you can kind of choose your own adventure depending on your application. If WMAS is too risky for you, you could use digital narrowband. If you need the lower latency, you could use the analog and be backwards compatible. If you want to send some data and ship it across a set to your Axiom Digital receiver, you can do all that. As mentioned, ETSI is the FCC of Europe, and they're the ones that kind of were the first to say, yes, you can do this, and there were some regulations. One of the small differences between ETSI and FCC in the US is that they limited the output power for unlicensed users a little bit lower, about 50 milliwatt shared. And in the US, Shure specifically argued with the FCC to say, hey, because of this whole shared power concept, the more channels we put in a block and they're going to be divided up, then we'd like to have the option of more power. And we made that proposition, and the FCC said, yeah, that's fine. And it's not any worse than using digital or analog narrowband. Again, another restriction with WMAS is that the system, in the wording here, the system has to be capable of operating at least 3 or more channels per megahertz. That's not a really high bar, let's be honest. We're already doing that with most modern, 6K or Axiom Digital. We're doing that in standard mode. And even beyond, like if we're using our HD mode in Axiom Digital, we're doing 47 channels in 6 megahertz. So that's well beyond the 3 megahertz requirement. Again, this kind of caveat or language in the law was put in there to prevent people from designing a system like, well, it's really awesome. It has the best audio quality, low latency, but it takes up a whole TV channel for one microphone. And that's that's cool, but not really the point or the spirit of what WMAS was intended for, and kind of, especially on the broadcaster perspective, when Spectrum is already at a premium, you don't want to kind of just waste it, even if you're getting some pretty cool stuff. Again, WMAS is not a technology, but your only things really is how wide you can use. You can use up to 6 meg in the US, and output power restrictions are still capped at a certain amount, depending on licensed versus unlicensed users. Talking a little bit more about like the vision for mixed usage, we do see legacy narrowband devices and WMAS coexisting together. Whether that WMAS is 800K or 400K or 6 meg, we're going to see all of that kind of mingled together, especially news events and festivals and you name it, where everybody just kind of shows up and brings what they have. This is going to be this way for some time. Even analog is still here to stay for quite a while. As much as people think we're all in a digital world, it's gonna do that. So we do see a mixed bag of stuff, and as you grow into your own kit, I think you will probably have a mixed bag of stuff. You probably do now with analog comms, for example, and digital wireless, that type of usage. And with that being said, we don't think WMAS is like the end-all be-all. We like it, we think it's cool. We obviously think it's cool because we put it in our product, but we don't think that's like gonna solve all your problems and like be like the only game in town. Maybe way in the future, that could be a thing. But for those reasons I mentioned, especially the output power restrictions, the range and the shared power, and then also the larger the target, what happens when you get interference, those type of things are things you have to think about when you're doing WMAS. A lot of people ask, they're like, oh, well, you came out with WMAS for Axient Digital PSM. Are you going to do it for Axient Digital? And to be honest, it really doesn't make that much sense because we're already achieving those type of channel counts that WMAS can provide with Axient Digital HD mode. So there's not really, to have a complete product redesign or a new hardware unit just to get a couple extra channels doesn't make a lot of sense when you can already use HD mode, which is predominantly what a lot of the broadcasters, or all of them, are using in New York City to maximize their channel count in narrowband mode. 47 channels per 6 meg. It's quite great. But that's about it. Like the brief overview. It's just kind of keep in mind it's a regulatory thing. It's not a technology. Every manufacturer has their own way of doing it and their own special sauce. The Shure approach is going to be different than the Sennheiser approach, and the Shure approach will be different than whatever comes out in the future. It's not going to be the same thing. And we designed, our first take into an actual shippable WMAS product to be of those things, to give you that option if you want to use it. But if you don't like it, you can click the knob and fire it back up in digital narrowband mode or analog narrowband mode and kind of coexist together. So the future looks bright. I think it's cool. We're obviously still on board the WMAS train, but we definitely acknowledge the existence of narrowband as well.
So with that, I think the most important takeaway for me is that WMAS is not one thing, right? It's a regulatory framework, and it's up to each manufacturer to implement it. I want to ask, is there a world where there are portable 2-channel receivers that are considered WMAS?
I think to Ben's point, that's something that might be easier accomplished with narrowband or another technology. You could see maybe leveraging this technology if you had more channels. You had 12 microphones and comms and IFBs and the devices that you showed on a film set. You may be able to combine those into that channel in the future. And it really is a multi-channel audio system. So to kind of 100% agree with Ben's point that narrowband is going to continue to be developed and improved on. This is another tool. So I mean, maybe, but I don't see a benefit for a 2-channel audio system. Maybe a 16 or a 32-channel audio
Totally,
system.
and I frame that because just by show of hands, how many people in the audience are mix on a sound card? All right. And how many people mix for E&G or news? Okay. So yeah, I mean, I think, and a couple of times people raised their hands both times. I think it's really important for our audience, film sound mixers, to think about specifically how the WMAS frameworks help them and could work for them. And each of you have an answer for that.
Yep. I do want to circle back to one thing you mentioned about the bigger target and kind of talk about how we approach that. So on that 6 megahertz wide carrier, our approach is that we took two technologies that have been around forever. TDMA, which you would use in some of your comm systems right now, or DECT-based systems in 1.9, where it's a time slot-based system. So nothing is transmitting at the same time. They're all kind of taking turns really quick in a TDMA scheme, a time division multiplex. And then for the interferer, like if somebody turns a microphone on it, our approach is to also take OFDM, which is to use many subcarriers, so hundreds of subcarriers across that 6 megahertz, and we put the same information across those subcarriers. So the information is redundant across the 6 megahertz, and if somebody turns on one mic, 2 mics on top of it, it's like a crash on a lane of the highway. The traffic is still able to get through bidirectionally. So I think you're right. If you had a one wide carrier, it's a huge bullseye. If somebody accidentally comes in with an ENG kit that's uncoordinated and took it out, that wouldn't be a very solid solution for a system. So that's how we approach it, by using OFDM.
And in the Sennheiser approach to all systems go quiet for a brief amount of time to scan.
Oh, the listening.
correct?
Yeah, so in the TDMA scheme, there's 128 audio resource time slots where any system can kind of transmit in that. And then there's a silent slot where the body packs listen and the receiving antennas listen as well. They're all transceivers transmitting information back and forth. And now the packs can report interferers now. So if somebody turns on a transmitter next to a body pack, it can say, hey, there's something interfering next to me. That communication is part of the carrier, and it's all going back and forth. The other thing you can do is mute the carrier in a scenario, and because everything's always connected all the time, or you can change the whole frequency, everything just goes quiet. So you can turn it on and off like a light switch.
All right, so I feel like, this is a lot of theoretical information, and this is a new technology, like something that we haven't seen in our industry ever, really. This is a completely new approach. So I think the way I want to make this more concrete for people, what problems do you need this to solve? What problems do you think this might solve? And let's get some real world examples. So Henry has the mic.
Yeah, my question is about, the regulations were 50 milliwatts for a 1 megahertz and 100 for a 6 megahertz wide channel. Are you allowed to go in between those sizes? And does that change the power requirements?
Well, off the top of my head, I think it's over 1 megahertz blocks can use the higher output power.
Yep.
Yeah.
Anything over 1 can go to 100 milliwatts.
Has the ability to use it.
And it's up to, so you can scale it up and down.
And do you imagine building systems where you could the user could adjust the width of the channel to what they need? So for example, let's say I just need 10 channels. I can make a narrower channel and be a better steward of the spectrum, something
That's a great
along those
question.
lines.
Yeah.
For our system, because of how we built it,
Yeah.
it's a 6 megahertz fixed channel. You could design a system for that, but it would be a different system in this scenario. So our approach to it is you can get a whole lot of channels bidirectionally in that one 6 megahertz carrier. But if you're going to use less than the 6 megahertz carrier with our current technology, you would use narrowband. The reason we did that was to reduce the effects of multipath and fading. With the 6 megahertz carrier, we can potentially use one antenna in some small spaces, and then it's easier to make zone systems with it. So for this particular system, you could develop something like that. It is a 6 megahertz, and it requires that. So if that doesn't fit your application, for us, you would go narrowband.
That's a great point. We, in our ADPSM system, there's actually two WMAS modes. So there's a digital 4-pack or 4 stereo channels in 800K, and there's also a digital 2-pack, which is going to be 2 channels in 400K. Most often the dual will have the 2-channel mode, right? And the quad will have the 4-channel mode. But in the next month, actually, in a future firmware update in June, you'll be able to use both of the modes on the dual and the dual on the quad, for example. Well, why would you want to do that? The main benefits there are if you don't need the extra channels, you can use a smaller WMAS block, being A, more efficient, and B, more powerful, because you're only going to be taking whatever the output power is and dividing it by 2 rather than dividing it by 4. So those are also, that provides capabilities of that dual channel, having channel expansion in the future. When we're talking about this particular product, you're basically a dual, it's 2 stereo channels, but it also is 2 radios. So each of those radios could do potentially a digital 2-pack mode or a digital 4-pack mode. So a dual, if you're into expanding it all the way up through licensing, you can have 8 channels of stereo IEM or IFB on that dual. And on the quad, you can do 16 channels of stereo or 32 mono IFB and 1 RU, provided you're using those WMAS modes. So it's not quite like your theory of moving a knob. That would be really cool, but technically difficult, I would say. A complete system redesign, complete codec and modem redesign. But we give you that flexibility with on this particular product. Of course, we'll see what happens in the future as well. So.
I want to give 2 real-world examples from each manufacturer, and you guys correct me if I fantasized about this application. In the Sennheiser implementation, 1 pack can transmit high-quality audio and receive high-quality audio at the same time. Mm-hmm. And so think about like a boom operator, right? That now it's just 1 pack and they're listening and receiving. In both systems, and I'll switch to Shure's implementation, there's multiple channels of audio going out at the same time to the packs. So for example, how many people deal with multi-camera reality shows here? Yeah. The idea where you have producers that need to listen to multiple camera feeds, where you have, from a single pack, or multiple, just multiple audio sources. Both systems can implement that really well, really efficiently.
Yeah, the one-to-many approach is kind of absolutely necessary for like award shows where you maybe have 16 channels of transmit and 128 packs and so forth. So there's no limit to how many packs you can have that's receiving, even with encryption, which is quite cool. And then the ShoreLink remote control would max out on a maxed out quad. You'd have like 128 channels of ShoreLink if you needed to remote control those packs. But a lot of times they're not remote controllable. But we've been involved with the award community, of course, and they have like a preset basically using Q mode just to flip through the different channels. So all the packs are the same. They can all receive the same 16, whatever the number is of channels of audio. And then while they're down on the floor, like, oh, what are you, a background dancer? Okay, and then just flip it over and hand out the pack to them, that sort of stuff.
And presumably because control is integrated in both systems, in that case, if it's somebody that's not technical,
right,
that can be remote controlled and they can be told.
Correct.
Like, oh, if you're listening to the dancer stuff here, let me use my iPad app and change your pack.
Yep. Yeah, the approach with ShoreLink is a little different. Like it's out of band management. So if there was an issue with the actual frequency that you're using or that block, then you do have it in a different frequency range for that command and control. And there's a term that's called network sync, which is kind of boring, but it's pretty cool. It basically means you can pick packs up that aren't part of the system and then say, hey, I want you to be part of my system, and then move them around, remote control them. And if I don't need remote control, I can tell them I don't want you on my system anymore. You can basically IR sync a pack that's out there without IR syncing it. You could say, hey, that pack on the table that's powered on, I want it to belong to channel 4. Oh, wait, I made a mistake. I want it to be on channel 1. You can do that through Workbench or the app or the front panel, which is pretty cool.
Yep.
So.
And our approach is the control link is part of the WMAS carrier. And it's bidirectional, so I can adjust somebody's headphone volume on the pot. I can see if there's the headphones are plugged in or if there's a disconnect. I can monitor this stuff as part of the channel. And we're working on the Q mode, so you don't have use any more resources to listen to mixes. We can have up to 128 packs listen to the same mono or stereo IM mix. It's the similar encryption scheme where we kind of cap out of that 128 on one carrier. The control also allows you to take resources and reallocate them among those 128 packs. So if you had the award show or the Olympic opening ceremony scenario, as a band finishes their performance, you can take their resources away from them and they go into a dormant mode, and you can give them to the next band, and you can kind of reallocate resources over that control link over the 6 megahertz carrier. It's built into the WMAS carrier.
Charles, I saw your hand up.
Yeah, my question is, if my setup is not on WMAS, and let's say I'm a block away from someone who is, will it be like coming in contact with another carrier wave, like how everyone had to jump off of other blocks that we were using for years and getting stomped on? I mean, like, how does my system avoid their system, or how does their system avoid my system?
That's a great question. Well, these are still digital, either digital narrowband or digital analog systems. So, I mean, intermodulation is pretty much not a problem as far as reacting with each other and creating harmonics and frequencies due to the linear nature of the amplifiers and the RF circuit. But yeah, it would be essentially almost like a mini TV station, maybe a lot less power, but you would still have to, kind of be cognizant of that. I mean, you cannot really. I mean, at least what I know though, WMAS, you can't really cooperate. Like if somebody has a WMAS block and they're taking up 800K or a whole 6 meg, you can't really park your stuff on top of them and expect good results, because you both need the resources that are in those blocks. So yes, you will have to navigate around those other WMAS carriers with your narrowband stuff. There's no real way around it.
Yep, it would show up as noise floor, like a DTV channel. We're able to adjust the power up and down on it, but best case scenario, you frequency coordinate, maybe put the WMAS carrier in the unlicensed part of the duplex gap, and then you operate, in the block that you have, something like that. So get separation, don't operate on top of it.
I saw Howard, and then we'll go to Jerry at the front.
Is the licensing attached to the device or the operator?
License specifically for channel expansion or for WMAS in general?
Or
Both.
Both, okay. Well, the majority of wireless users, and I predominantly are unlicensed users under Part 74, right? You can get a Part 74 license and be a licensed user, which provides you access to more spectrum and greater output power and such, but these systems are both of that. They're designed for both unlicensed and licensed users. Anybody could simply buy this off the shelf, no problem.
Okay, so going to the FCC for Part 74 licensing,
Absolutely a great idea. I mean, you can access higher output, but there still are like some restrictions in the U.S. and the FCC as far as output power goes. I think the official kind of gotcha is that in the United States, each box with an FCC sticker on it can do 250 milliwatt max, all in. And regardless if it's 2-channel box or a 64-channel box, it doesn't matter. And then that's also the concept of taking that power and then you're whacking it up however many times you're whacking it up. Kind of like taking a pie and how many slices you're cutting it into, yeah.
And Harold, stay tuned for the next seminar. Yeah, it's great.
oh, for sure.
Yeah, for sure.
Jerry, I saw your hand up as well.
So let's say you're in Times Square. You get there at 8 in the morning, and then you're shooting until 10 o'clock at night, and all of a sudden the theaters come on, and you were clear early in the day, and you've chosen your part of the spectrum, and then it changes, and you're not necessarily going to have cooperation with all the theaters. The theaters have cooperation with themselves. They know which part of the spectrum, but I don't. How flexible will I be able to be in that kind of a situation?
So for our system, if you're in TV UHF, if you need to change the frequency in a quick manner, you find, okay, theater fires up, it's on your carrier. It can handle a certain amount of interference because of the OFDM scheme, But if you find yourself in a scenario where there's 16 high power carriers on top of you and it's, there's just no way for that, information to get through, if you change to a different 6 megahertz carrier, the whole system will just jump together. So you don't have to do pack syncing and that kind of a thing. We talked about part 74, we're also looking at the AF-track band. So a lot of part 74 users have expressed interest, and you need to have that license in order to use it. It's spectrum that's currently used for flight testing and training. You can lease it. So it's kind of a clean spectrum where that's available to part 74 users as another option with the system. But if you get that sudden interference for the 6 megahertz, you would tune to another frequency and the system would jump.
So the systems would alert you and then
Yep.
would tell you to move, or
It'll show interference. The pack will note I have a narrowband carrier and it's on 545, 450. It'll show you on there.
A couple things to add. I mean, that's one of the reasons why we chose, in this particular ADPSM product, WMAS mode to be more efficient and more narrowband, because we didn't mention it yet, but with the WMAS rules, you cannot straddle TV stations. So if channels 25 and 26, you have to stay your block completely inside. So for if you're taking up a whole 6 megahertz, you're gonna have to find a whole another 6 megahertz that's clean, that doesn't have anything in it, in order to move that block there to have good performance, right? And in New York, it's pretty difficult to find 6 megahertz of contiguous spectrum that's has anything in it, unless you're not in the UHF band, right? Which Chris was talking about. Maybe other spectrum ranges might be a little bit better, or you're in a shielded facility. You're some Broadway theaters and Madison Square Garden and others have some pretty good brick and lath and plaster and all that kind of mitigates the RF from the outside. So that could be your friend in those kind of Faraday cage examples. Having more flexibility and being able to dodge those other carriers that may pop up is really a good thing, in our opinion.
And there is going to be instances where narrowband systems are a lot more agile than a WMAS system, no matter the width, just because it's a wider carrier. So if you have the 2 channels and that's what you're shooting in Times Square, that's probably best used for a narrowband system. It's more if you have to get 16 channels for your shoot in Times Square, and then all of a sudden you find information and you have 16 narrowband channels that you have to reallocate. That's hard to do for that as well. You'd have to find another clean 6 megahertz block or places where you can stash all those channels. So it's really meant for multi-channel application, smaller channel counts. It's better to use narrowband.
I do want to contextualize what you're saying, because multi-channel for a lot of film sound people isn't just the talent wireless, but it's the high quality IFB feeds, it's the Comtex, it's the the sends to camera. And in our world that can encompass, we pretty quickly, even on a typical episodic show, go up to 16, 20 channels when you start to think about all of those different feeds and incoming and outgoing. Yes.
This is a listen only. We're talking about PSMs. You said for the mics would only be narrowband.
Ours is bidirectional, so it can be a microphone and an IM or IFB on that same 6 megahertz resource. So you can share both at the same time, which is tough to do right now. Usually we sandbox our IFBs in one TV channel and we have our mics in another TV channel. Now it all shares bidirectionally.
Right, and that's the tricky thing when talking about both systems is they're both considered WMAS because they fall under that regulatory framework, but they're radically different implementations.
Yep.
And one is bidirectional, meaning audio goes both ways, and one is unidirectional right now at the present time. Things are always happening, right?
Yeah, this is all new. So this is our first idea,
Saved.
Yeah.
And I just have one more question. In
Yep.
the WMAS mode, what's the difference in transmission between the narrowband? You said, obviously if you have a high channel count, you're using WMAS. What's the RF output power difference? When would you say, hey, I should use narrowband for this because I want to go further,
It's a different implementation, and you can go first, Ben. if you
Yeah,
want.
I was going to say, well, because the Spectera system is WMAS only, right? Well, the ADPSM gives you 4 different options of which modulation you want. So you can choose WMAS, or you could choose digital narrowband, or analog narrowband, or point-to-point accent digital. So if you don't like those modes, you can change them. With the output power, I mean, this could be like a whole seminar on itself, but the basic way to think about it is that you have a limited amount of resources per radio. Like, let's just call it 100 milliwatt, say per RF spigot. If I'm using that in digital narrowband, I could use perhaps all of that for one stereo pair of microphones. If I'm going to use a 4-pack or 4 on a WMAS block on that, I could take that 100 milliwatt and chop it up by 4. So realistically, each user of that block, each stereo pair is going to get 25 milliwatt, right? And then there's all kinds of permutations as far as like adding extra features. Like we have a feature called spatial diversity where you can put 2 antennas transmitting on the same frequency at different times for better reliability. That will impact it. Again, the architecture of the hardware itself will impact it. If, let's just say 250 is the limit, but if a box has 200 milliwatt, like all in, a dual will be able to have 100 milliwatt per RF spigot. If I'm taking that 200 milliwatt on a quad on 4 radios, now I can only have like 50 per spigot. And then I'm whacking that up by 2, by 4, depending on how that goes. So the answer is it's super complicated, but envision it as a pizza or a pie, and then how many times you're dividing it with some other things. The good news is that on the screen itself, as you're scrolling through what we call operational presets or the modes, it'll tell you what your realistic output power is going to be expected in that particular mode, which is great because there's like 40 or more different modes. I can't memorize them all.
I encourage you guys to go by both booths and really play with it, and I want to compliment both of you. The GUIs on both systems really do a great job explaining what's going on under the hood. Yeah, I mean, it's definitely sort of a new paradigm for us, a new way of thinking, and it's not appropriate for everybody in every scenario. But having just 2 reality shows, competition reality shows shooting in New York, both of these systems would have been huge hits at that system, at those shows. I think we have time for one more question. I see a hand way in the back there.
In regards to resiliency, you mentioned with the Spectera, it can take some interference. I remember hearing like 2, like not necessarily mentioned here, but I was wondering if you don't use the full capacity of like all available channels that you can squeeze into the 6 megahertz, if you reduce that to maybe half, does that increase the resiliency because you're sending the same?
So it's resilient because of the OFDM scheme. So the information of the time slots, whether they're used or not, is going to be duplicated across the carrier. It can handle interference because of that scheme, but whether you fill it up to 100% of the available resources or you're using 25%, it's always the same. And then the power, and the way we do it a little different with TDMA is nothing is ever transmitting exactly at the same time, so it's kind of like double Dutch. It's like transmit, and jumping in and out. So it really, the system is always transmitting at 50 milliwatts or 20 milliwatts or 30 milliwatts. You can adjust that up and down depending on how you want to contain it or reuse it in a neighboring space, that kind of thing.
All right. I think we should leave it here, and definitely the beauty of this arrangement is you can go check out their booths and ask more questions and get it in your hands. That's really the key thing. Thank you, gentlemen, so much.
Thank you.
Thank you.